Welcome to PowerUp, a podcast show hosted by Maurizio Di Paolo Emilio that brings life to some of the stories on power electronics technologies and products featured on PowerElectronicsNews.com and through other AspenCore media publications. In this show, you'll hear both engineers and executives discuss news, challenges and opportunities for power electronics in markets such as automotive, industrial and consumer. Here is your host, Editor-in-Chief of PowerElectronicsNews.com and EEWeb.com, Maurizio Di Paolo Emilio.
Hello everyone and welcome to this new episode of PowerUp. Today we explore the dynamic world of semiconductor technology and its ever-evolving talent landscape. We have Jason Dubin, Vice President of Executive Search at SBT, an experienced recruiter with 8 years in semiconductor field who has connected with thousands of engineers. We will delve into the booming power management integrated circuit PMIC market, the shift from silicon to wide-bandgap, such as gallium nitride and silicon carbide, talent sourcing from industries like automotive, aerospace, and the impact of government initiatives like the CHIPS Act, and so on. So let's talk with Jason. Hi, Jason. Thanks a lot for being here. How is it going?
It's going great. Thank you. Thank you for having me, Maurizio.
Absolutely. Thanks a lot for your time. Today, we will talk about this dynamic world of semiconductor technology in different aspects. So first of all, please introduce yourself, Jason, to our community. Tell us a little bit more about your background.
Yeah, sure. My name is Jason Dubin. I am the Vice President of Recruiting here at SBT Industries. We're an executive search firm that is specialized within the semiconductor industry for going on. This is our 35th year anniversary of doing such. We are headquartered in Phoenix, Arizona in the U.S., and I have been recruiting specifically here at SBT for just under 9 years, and in recruiting in total for just over 12 years. And my previous life in the legal world as an attorney has served me well within the recruiting industry. Nice.
So let's start talking about power management integrated circuit market, PMIC market. So can you give us an overview of the current growth trends in this global market, global PMIC market, and how this surge is impacting the demand for specialized talent?
Sure. No, absolutely. And, we're lucky enough to interface with a lot of engineering leaders and hiring authorities that sit front and center within this industry, and specifically in power management. So the insights we're able to get are really very fascinating, especially where we're at right now, because the PMIC market, power management integrated circuit market, is experiencing significant growth and evolution, which is really driven by advancements in a few core industries. At a high level, the big umbrella is really, within consumer electronics, automotive, telecommunications, as well as industrial applications. So those are kind of your big ticket arenas of advancement. And breaking that down a little bit, you kind of have to start the conversation with regard to trends, and the things that we get to hear about quite a bit recently are and as everyone else sees physically, is the growth in automotive and specifically electric vehicles, and the role that power management and PMICs play in EVs is pretty interesting. The electrification of vehicles is really driving demand for automotive grade PMICs. That's kind of a new thing now with regard to the automotive grade side. The stringent reliability and safety standards that are required in automotive applications has opened up this whole new avenue of PMIC development, and these PMICs within EVs, they need to handle high power levels, and they need to support fast charging. And then the other aspect is the battery systems. Every year we kind of see, these EV companies, these car makers developing and putting out cars that have longer mileage, which means longer battery life. And so PMICs are playing a critical role in EV battery management systems. And so that specifically is about better monitoring, balancing of battery cells to extend range and battery life. So I would be doing it a disservice if I didn't start with the automotive space. Moving into what's going on in consumer, it's about integration and miniaturizing the PMICs. There's kind of this really unique trend, and this has kind of come up a few times over the past few months specifically, but there's this trend towards integrating multiple power management functions into a single PMIC to save space and reduce component count. And, this is really where consumer kind of plays most of its, plays most of its, its integration within smartphones, wearables, IoT devices. You see a lot of that. And then, shrinking the PMICs is also becoming more important, because going smaller while maintaining improving performance has been key. So that you see that more in packaging. So you'll hear about buzzwords, and we've been talking to a lot of people that have been bringing up the need for people with wafer level packaging experience, or even something called system in packaging. And so that's an interesting trend as well. And then this can be a very long conversation if I wanted it to be, but I also don't want to miss the aspect of what's happening with GaN and the silicon carbide adoption with wide bandgap semiconductors. That's been a significant trend that entire conferences are centered around what's going on in the wide bandgap world as well. So those are just a few of the numerous trends, and simply put, what's going on, it obviously directly affects not only with the advancement of technology, but the need for talent. And so these conversations with these leaders and hiring authorities within the semiconductor space start with, we need people that can come in and do and continue this advancement. And there is a dearth. There's a dearth of talent out there that they come to us and they look for this. They're looking continuously for people that can help advance this. So as the hockey stick trajectory goes up with the advancement of tech, so does the need for talent.
Yeah, indeed. In terms of technology, you mentioned the wide band gap, you mentioned gallium nitride and silicon carbide. They are important for electric vehicle electrification trends. And let's talk about the transitioning skills from silicon to wide band gap. Yes, gallium nitride and silicon carbide. So what are the key skills and experiences that engineers need to transition from traditional silicon components, silicon development, to GaN and silicon carbide technology? How can they best prepare for such a shift?
Sure. Yeah. I wish it was apples to apples, because if somebody is sitting there as a silicon developer doing kind of traditional power analog design, and are highly interested in moving to the wide bandgap space, there's pardon the pun, but there's a big gap. We've heard feedback from hiring managers over the last few years that they do interview a lot of people from the silicon side who are highly interested in diving into the GaN or silicon carbide or just the material space. And that gap in the materials experience is kind of the first thing they bring up. They say, we'd love to bring on this great engineer who's been doing some really interesting things in silicon, but the first skill set that individual really tends to lack is that materials understanding. They may have a double E academic background, electronics engineering, electrical engineering, but not having that material science. That's kind of key skill set number one. Understand material properties for the higher band gap, which plays into understanding thermal management, because both GaN and silicon carbide have a much superior thermal conductivity compared to silicon, which impacts cooling and heat dissipation strategies. So, this has been a constant theme from hiring managers saying that is one aspect that we really like to see is understanding of material properties. And so, this affects everything from the circuit topology, to characteristic to the simulation tools. So then one skill set that somebody can try to gain is to learn to use simulation tools that are tailored for wide bandgap materials. They can model high speed, high temperature behaviors.
Mm-hmm.
So that would be an area for someone who's doing silicon to really focus on understanding the simulation tools. And then I would kind of end with, although there's regulatory and reliability considerations, thermal management, thermal packaging considerations is a big ticket skill set for somebody kind of moving into that as well. So studying the wide bandgap characteristics, doing as much as you can and understanding the design approach. There are conferences you can go to. There is a lot of self-study that would be involved, but it really goes back to the core of when somebody studies material science, they're getting a very different level of exposure to what's happening in wide bandgap. So I wish it was easier for silicon to kind of translate to that wide bandgap space. It's possible. But those I would say are the key skill sets that to summarize: the material properties, the understanding the different circuit topologies, and the characterization and the simulation tools, and with regard to all things thermal.
Yeah, thermal. I totally agree. And also packaging would be very important to have successful in terms of wide band gap. Talking about talent sourcing from other markets, such as automotive, aerospace. So which markets offer rich talent pools for the semiconductor industry, particularly for PMIC development? What skills from these markets are highly transferable?
Sure. Yeah. And, you mentioned too, right off the bat there, aerospace and electric vehicles. If we're looking at generalized skill sets, what you kind of hear these buzzwords of somebody working and understanding how to design within power distribution, power efficiency, power regulation, power delivery. Those are probably the core skill sets that you'll see outside of your traditional semiconductor companies. And like a good example would be the electric and hybrid vehicles, ADAS systems, the advanced driver assistance systems, and autonomous driving, those Waymo cars we see, they rely on PMICs for efficient power distribution and management. So, although those companies may not be developing their own silicon, you've got engineers that really do understand that power distribution skill set. If we're looking at industrial manufacturing space, which is obviously ancillary, periphery to semiconductor. PMICs come in all shapes and sizes within automation systems and robotics and these control systems for the industrial applications. They're there to ensure reliability and really that efficient power management skill set. And then you mentioned aerospace, defense, renewable energy, solar inverter technology and wind turbine controllers, and energy storage systems use PMICs to manage power conversion. I don't think I mentioned the conversion piece. So you've got power conversion, which then translates to the distribution aspect as well. So, medical device also plays a significant role as well, with, efficient power, management. So those would be the industries that I would be looking at. And we've talked to some leaders that have, you see some of these companies, taking, a intentional look outside of your traditional semiconductor players to find that type of talent.
Let's say that power management is everywhere in this case. So, talking about the impact of government investments. So, our initiatives from politics, government, like CHIPS Act and other private partnership are contributing to the development of a stronger talent pipeline in this semiconductor industry. So, can you share some examples of successful collaborations?
Yeah, no, absolutely. And this is it's really exciting what's going on, as we speak. With the CHIPS Act, it kind of focuses on three things: funding for education and training, research and development, and then workforce development. That's really their goal, is to support apprenticeship, support education, really, at the end of the day. The successful collaborations that I've seen so far, the easy ones that you can see, you can Google and you can see what's going on with the big, the big developers, the big wafer manufacturers, the Intels, the Microns, the Global Foundries. You hear about those, you can see those in the news, the Texas Instruments. But what's really fascinating about what's happening with the CHIPS Act is this combination of these collaborations between public and private. These, private institutions working with academic institutions. There's a few universities. There's Semitech, which is a partnership between the U.S. government and private semiconductors. It's been very successful. One that actually is in my backyard here, Arizona, with TSMC establishing a presence in the U.S. About 15 miles from where I'm sitting right now, and Arizona State University, they've partnered, ASU has partnered with TSMC to create a specialized training program for students. And so this is, CHIPS Act funding has gone directly to this. And so TSMC's new manufacturing facility has kind of spurred this idea with ASU's Microelectronics Commons, and they're offering a tailored course catalog and hands-on training that prepares students for roles in semiconductor fabrication and process engineering. And that's a really good example of this trend that we're seeing of companies like TSMC. Samsung is doing this type of collaboration in Austin with University of Texas at Austin to develop programs based on advanced semiconductor manufacturing. And so these are already happening. It's not like they're planning for this. These are already going on. There's a really cool program up in Albany with IBM that's been going on for a while that the CHIPS Act has considered a very, very important growth aspect of the cross-functional academic and kind of private institution relationship, because it's going to interest these students, these researchers, and then joining these companies after they're finished with their master's or PhD programs. So really exciting partnerships going on because of the CHIPS Act.
Yeah, exactly. So we can see more collaboration in terms of companies, academic, public institution. So the bridge between university and the company should be close, very, very close in this case. So nice chat, Jason. But before closing, I have the last one to you. So looking forward, looking ahead, talking about the future talent strategies. So we talked a lot in terms of talent sourcing. So looking forward, what strategies do you recommend to semiconductor companies to effectively attract top talent in this market that is going to be competitive even more? So how important is continuous learning and upskilling in this field?
Sure. Yeah. And what you just said, the growth, what we've talked about here is the amount of growth from a technical standpoint is going to be creating significantly more jobs already. And then the CHIPS Act and the government funding is adding just, I'll call it fuel to the fire, a lot of fuel. And there's not enough people to fill these positions. Mm-hmm. And so it's a common question. How can we attract, and not only attract, but retain engineers, quality engineers, people who are passionate about this power management, and just in general, it doesn't even have to be power management. And what we've seen from an attraction standpoint, an example I'll actually bring up, we had a really good conversation with Dr. Alex Lido, who is the CEO of a company, Efficient Power Conversion, yes. And what obviously very well respected individual and a pretty big name in the industry, and what they've been doing to attract people, and I thought this was really unique, is they're attending as many conferences as they can domestically and internationally, and having that interaction with the current individuals who are in school, who are attending these conferences, getting out in front of as many students, as many researchers as possible to show what it is they're doing is really kind of step one. And so that's something that they've made a point to do, and they found a lot of success. Another advantage that Dr. Lido has is that they've developed peer-reviewed textbooks that are in the hands of students who are studying this exact, space within power management or compound material science, and having that in the hands of students is something that has been something they can't replicate. They can't put a value on it, but they know it has helped in attracting individuals to their company. And so I thought that was a really unique and smart approach to making sure that you're not just relying on the company's success as a whole or certain patents to kind of reach the public domain, but they're actually taking intentional efforts to get in front of people. And that's on the attraction side. On the retaining side, it gets a little bit more complicated because for smaller companies and growing companies, it is difficult to keep larger companies away from just, buying their candidates and spending, overspending, overcompensating. And so one thing that we've helped guide leaders in understanding how to construct their organization is we rarely hear individuals and engineers saying, I don't want to leave my current company because I have such a strong connection with a mentor, or they're really invested in my career. And investing in the engineer's career from the standpoint of mentorship, keeping them engaged, allowing them to continue to expand their skill sets, not siloing engineers, is really the best way to keep them engaged. Show them that you are passionate about their career as much as they're passionate about their career, because that's the reason why they joined, is to grow, or at least we hope so. And so that kind of plays into the continuous learning and upskilling for individuals that are currently employed and you want to retain if you're a leader, is keep them engaged, keep them excited, give them challenging projects, and get ahead of that before they start asking, because mentorship is something that is kind of a lost art in this industry. And because people jump from company to company so quickly, they don't have that consistency. So that is one thing that we've heard, that we've seen us being a success, is investing in your employees, investing in those engineers, and really, really showing them that you want to grow their career.
Great. Thank you, Jason. And you mentioned Alex Lido. So I have the pleasure, I talk with Alex many times. He's a great industry leader, and we have the pleasure to have Alex in a couple of weeks in Milan for PowerUP Fortronic event. He will give us a keynote talking about gallium nitride, how we arrive at GaN from silicon. That will be a nice talk. Thanks a lot for your time. It's been a pleasure to have you. Really nice chat, and stay tuned. Thank you.
Yep, my pleasure. Thank you.
That brings us to the end of this episode. Stay tuned with more news and technical aspects about power electronics. If you are listening to this on the podcast page at eetimes.com or powerelectronicsnews.com, links to articles on topics we have discussed are shown on this page. Power Up is brought to you by Aspen Core Media. The host is Maurizio Di Paolo Emilio, and the producer is James Eade.